installment of notes and practice for your statistics unit. Again, the statistics unit is being done at a self-paced. It is not something that you will run into next year in pre-calc or even in advanced math. It's its own little standalone topic, subject matter. You will see it again if you take probability and statistics, and some of it you may see again in advanced statistics. Either way, all of this information will be taught as if you've never seen it before. So, with that said, again, this is just in preparation for this SOL. Z-scores. Z-scores are special. It's a value that shows how many standard deviations a data value is from its mean. A z-score allows us to take these normal curves. They can all look a little bit different. They can all be, some can be tall and skinny, some can be short and fat, depending on the variability. And it creates what we call a standard normal curve, where the mean is 0 and the standard deviation is 1. You're 1 standard deviation above, 1 standard deviation below. And everybody fits to it using a z-score. When the z-score is positive, the data value is above the mean. When the z-score is negative, the data value is below the mean. This information is right there, and there are notes that you should be filling in. When z is equal to 0, the data value is equal to the mean. Reason being is here's the z-score formula. Z is equal to x, which is your data value, minus mu, which is the mean, divided by the standard deviation. Now, this formula, do you have to memorize it? No, no, no. It will be on your formula sheet, so don't worry about memorizing it, but you do have to know what each item means. Now, examples. A radar detector records speeds of a group of cars that pass by. If the mean is 46 miles per hour and the standard deviation is 2.8 miles per hour, find the z-scores for each data value. Well, you plug in for every last one of these. Notice that 46 is what's being subtracted because 46 is the mean. And then everything is being divided by 2.8 because the standard deviation is 2.8. And then the data value, well, that's what you start with. Okay, that's what you subtract the mean from. Alrighty, 52 is above the mean, so it's a positive z-score. 42 is below the mean, it's a negative z-score. 47 is just barely above, it's a smaller z-score. It's fewer standard deviations away. As a matter of fact, it's not even an entire one, it's part of one. Now, if you're simply being asked to find z-scores, all you have to do is be able to use the formula and plug the numbers in. So if we look at number 3 here, okay, the mean number of total miles ran last week by each member of the track team was 4. That's your mu. Okay. With a standard deviation of 1.2. Standard deviation. Oops, don't know why. There we go. If Clay's z-score was 2.5, how many miles did he run? So what you're being asked is, X is your question mark. That's what you don't know. So when you come over here, you're going to put your 2.5 in for Z. You're going to put your 4 in for the mu, and you're going to put 1.2 in for your standard deviation. When you do that, you get an equation that looks like this. Z, which is 2.5, is equal to X, that's what we don't know, minus the mean, which is 4, divided by 1.2, which is the standard deviation. When you multiply both sides, when you go to solve this, okay, you can multiply both sides by 1.2. Gives you 3 is equal to X minus 4. You're going to add 4 to both sides, and so your data value is 7 miles. All right, using the same information for using the same formula, for number 4, look at what you're given and find what you need. Pause the video and try numbers 4 and 5. Great. Did you finish that up pretty quickly? Well, For this one, you're looking for the mean. So of course, the mean right here is what is left. Multiplying both sides by 5. You put everything where it's supposed to be, and then you multiply both sides by 5, and then you can subtract 83, and then you're going to have negative 85 is equal to negative mu, so you multiply them both by -1, and you wind up with a mean being 85. Next one up, the heights of a group of trees is normally distributed with a mean of 14.3 feet and a z-score of 20 foot tall, and 1.9 is a standard deviation. Or, sorry, the z-score for a 20-foot tall tree is 1.9. What is the standard deviation? So again, you've got your z-score. You've got the height of the actual tree is 20. You're subtracting off the mean, and you've got the standard deviation. You're going to multiply both sides by the standard deviation, and then divide both sides by 1.9. And then notice, quite conveniently, these guys cancel, and your standard deviation is equal to 20 minus 14.3 divided by 1.9, or 3. 3 is on the high side. It's greater than the mean, and it's quite a bit more than the mean. If your average tree is 14 feet tall and you got a 20-foot tall tree, that's quite a bit taller. So, especially when you find out that your standard deviation is 1.9. All right? Good job. Now, the whole reason for our z-scores is the standard normal curve. This way, anything that's distributed normally can be applied to the standard normal curve, and then we can talk about things apples to apples, okay? If you just talk about one piece of data versus another piece of data, you're talking apples and oranges. You have to put them onto the same scale. So, the original distribution of x values is normal, and the corresponding z values will be normally distributed. The z distribution will have a mean of 0 and a standard deviation of 1. Above is the resulting curve, called the standard normal curve. This is the curve that all normally distributed data is standardized to when computing z-scores. Again, this is the whole reason for z-scores. You have SATs and ACTs, both are college entrance exams. One is based on a score from 200 up to, I think, 800 and 800, 1600. We'll just go with the two main ones. And then you've got your ACTs, which go between, I forget the lowest score, but up to like 36. So if you got a 30 on your ACT and a 900 on your SAT, which one did you score better on? You don't know. It's not linear. So you would have to take and look at the standard deviation and the mean and standardize the scores using z-scores. And then you could compare them. So again, the z-scores are just a way of standardizing things so that they can be better compared. Now, when we're using technology, we can use the graphing calculator to determine the area between two values under any normal curve directly. Means you don't even have to calculate z-scores. Besides being direct, the calculator is often more accurate. Now, this is for when those data values don't correspond with exactly 1, 2, 3 plus or minus standard deviations from the mean. Okay? If they do, you can use your empirical rule. Otherwise, you're going to need to use the calculator. Now, here's the funny thing. The calculator will do it, and you don't have to compute z-scores. If you use Desmos, you still have to compute the z-score. At least I haven't figured out the way not to. There might be one out there, and if and when I do, I will show it to you. Either way, it's not too bad. For the calculator, you're going to press the second vars button. And you say, what? Okay, here's your second button. Here's your vars button. So when you turn it on, clear, you would hit second vars, and notice you see normal PDF. We're not going to be doing a probability density function. Normal CDF, we are doing the cumulative distribution function, and we'll also be looking at using the inverse norm. Okay? Right now, what we're talking about, though, is the normal CDF. And when you do that, whoops, I'll bring that back here. When you do that, if I come down here and I do the normal CDF, it's going to ask me for my lower bound, my upper bound, the mean, and the standard deviation. So if I were to say that something had a lower bound of 5, an upper bound of 14, that's not what I wanted, a standard deviation of 9, a mean of 9 and a standard deviation of 2.6. When I paste, when I come down here and I paste it, it puts it into this whole command. If you don't have a newer calculator, if you were blessed to have one of the older TI-83s because you had a sibling who bequeathed it to you, well, then yours just comes up and it says normal CDF, open parenthesis, bleh. And that's where you actually have to type in the lower bound, comma, the upper bound, comma, the mean, comma, the standard deviation, which is just what happened here, normal CDF, open paren. Lower bound, upper bound, mean, standard deviation. And then you press enter again and it comes back and it tells you your standard deviation. Okay? Now, get rid of that for right now. We're not going to look at the inverse norm. We are going to look down here at some examples. It's a little bit easier to do. Numbers that I don't just make up off the top of my head. So, given a normal distribution of values for which the mean is 70 and the standard deviation is 4.5, find the probability that A, the data is between 65 and 80 inclusive, probability is greater than or equal to 75, probability is less than 62, or the 90th percentile for this distribution. Okay, so let's start. We're going to look at find the probability that a value is between 65 and 80 inclusive. That means I'm going to take my calculator and I'm going to turn it on. I'm going to do second vars, normal CDF, which is number 2, and I'm going to say that I want something that's between 65 and 80 if 70 is my mean and 4.5 is my standard deviation. And notice I get 0.853. See, it's the same thing there. This is the probability. The percent of the data that's between 65 and 80 is 85.3605592.5%. Okay? Now, down here, and I have that you have to give the answer. It used to be that you had to give the directions on how you got it, meaning you had to write down this command, normal CDF, blah, 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 blah. Not so much anymore because you could also potentially have used, you could have used Desmos, which is a little bit more difficult. Okay? Desmos requires you to find the Z-score. We're going to go over that in a little bit. So let's first go down to this next one. We want to find the probability that a value is greater than 70. Nope, did not want to do that. We want to find out that a value is greater than 75 given the same mean and standard deviation. Well, for this one, again, we're going to do second vars, and you should be doing this with me. Pause the video, get your calculator, second vars, normal CDF. Well, I want to find the probability that a value is greater than or equal to 75, which means that 75 is going to be my lower bound. My upper bound is going to be huge. Now, they have type in 1 EE99. You can also just type in 1 just a bunch of zeros. You just want it to be really big, more than 4 or 5 standard deviations greater, and you're fine. Okay, so just type in 1 with a bunch of zeros. Your mean is still 70, and your standard deviation is still 4.5. So we just scroll it on down and we say paste that puppy in there and go. And there's a 0.1332 probability that you have equal to, greater than, or equal to 75. Now, probability that it's less than, very similar, second vars. Come down to my normal CDF. My lower bound, well, I want to find the probability that a value is less than 62. So this just means it's going to be negative, and then 1, 0, 0, 0, 0, 0, 0, or I could also do 9s. I could do anything, just put a whole bunch of them in there. Then I come down to the next one. I can hit clear. My top range is going to be, or the top is going to be 62. Everything else is the same. And I come down and I paste. And I hit enter, and 0.0377. So the probability is 0.04. Okay, or about 4% is less than 62. The big thing here is just know if you're asked less than or greater than, you just make the number that's your upper bound or your lower bound respectively, super big or super small. Now, this last one here is find the 90th percentile for this distribution. Given a probability region to the left of a value, determine the value using the inverse norm. I want the 90th percentile. Well, you still just do second vars, gets you to our distributions, and here's your inverse norm. So I say inverse norm. The area, remember that the area under the standard normal curve is 1. So the area is going to be the probability, not the percent. So 0.9, and then the mean we said was 70, and the standard deviation is 4.5. Come down and I paste, and I hit enter, and it tells me that if you have a score or a value of 75.76666, etc., then you are in the 90th percentile. Okay? 90% of the data is below that number. That's what it's telling you. All right. Now, standard normal. Go back to your notes. Notice some of this is drawn in there, shaded and stuff, but you got to write the numbers. A normal distribution in which the mean is 0 and standard deviation is 1. The distribution is standardized by the z-score. It's simply saying how many z-scores away from the mean. Any mean could be different, but every mean is the middle, so that's 0. 1 standard deviation. I could go 5 steps for one thing, 10 steps for another. But they're still both 1 standard deviation. 2 different tests. Now, this particular thing here, I'm not even going to spend a lot of time on it because it's silly. It's how do you shade? Well, you all should be able to shade, okay? If I tell you that something's between 1 below and 2 above, you should be able to shade that area. If you know the standard deviation, you know about where it is, you should be able to draw a line and shade it. So I'm not just sure what this does here, why you're drawing that graph. That just, you're not going to need that. So don't worry about it. It is there on your notes. If you want to play around with it, feel free. Now, these guys, I want to show you a couple of things. The golf scores in a tournament, is normally distributed with a mean of 76 and a standard deviation of 2.6. Find each probability. Now, want to make sure that you are paying attention to the information you're given. Okay? First, notice this guy. The probability that Z is less than 2.1. The Z-score, not the data value, the Z-score. Since it's the Z-score, and 2.1 is not just 1, 2, or 3, so you're going to have to use the calculator. This one, you're going to do one of two ways. Dun, dun, dun. We can have our calculator, and we can clear it. We can do second vars, normal distribution, and I want to know if it's less than, so negative 1e99, that's fine. My maximum is going to be 2.1. Since we are talking about the z-score, not the data scores, the z-score, my mean is 0, my standard deviation is 1, so I just come down and I paste. Oops. And I hit enter, and it's 0.9821, blah, 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 blah. Great! Okay, so that's how you would do it using the calculator. What if you had Desmos? Well, here's Desmos. Desmos, again, remember you're going to find, let me move this little guy out of the way, functions. This time we're going to look for distributions, and we want normal distribution. I had to stop and think. Normal distribution. The mean is 0, okay, and the standard deviation is 1. We want to find the cumulative probability. So now this one says negative infinity to infinity. So up here I want the max to be 2.1. There's my answer. If you look down below, you want to know what's the probability that's greater than negative 1.5. Well, here, negative 1.5, and here, okay, the probability that it's greater than negative 1.5, I've got that. And if I want in between the two, negative 0.2 and 1.8. There's my probability for those z-scores. Okay? Now, and here's this little guy if you want. Okay? There's our probability curve. And I believe it actually shades it. Let me see if I can do... graph settings. That's it, graph settings. So if I say that I want x to go from negative 4 to 4 by 1s, and I want the y-axis to go from negative 1.1 to 1.1, steps of 0.1. Okay, now you can see how Desmos has graphed the normal curve for you, and it's also given you your normal distribution. Okay, now I went through and I did all of these because I don't remember if you do this guy, if I just get rid of him and I go up to 2, see, I go up to 2 and all of this. And again, this is not just the empirical, okay? 2.1 goes a little bit past, right? So this will graph it for you. So if you had to shade something on your paper, you could use this. The calculator, yeah, you can do it, but it's a pain in the rear end to remember all those button pushes. I would think that you all can shade this pretty easily. So when you've got the z-scores, easy peasy with the Desmos. When you are looking at the actual data, that's where the calculator right now is better because I have not yet figured out how to take it out of the normal distribution and just do it without having to calculate. So let's take a look on this side, on the right-hand side of your notes. Where the calculator becomes easier is when I've got the probability that my data is less than 74. Well, I do my second vars. I come down, I'm going to do my normal CDF. My lower is still negative 1 point E, negative 1 E 99, big, huge, or very small, huge, little number. My upper value, instead of being a z-score, it's an actual data item, so I'm just going to type in 74. My mean is no longer 0 because it's not standardized. I'm looking at the normal curve of just the data. So that's 76, and the standard deviation is 2.6. And I press enter, and I get 0.2208, on and on and on. And again, this might be a little bit different because I used 1E99. Depending on what you use as your lower bound, you come out with something a little different. Not to mention rounding. If you round here, you're going to get something a little bit different. Now, when you go to Desmos, the problem is Desmos does everything based off of the standard normal curve. So what do you need? You need the z-score. So you have to simply put in 74 minus 76 divided by 2.6. Not hard. The formula is given to you. But you have to first, oops, maybe, come back to 10. You have to first get your z-score. Okay, so I first have to get my z-score here. And it doesn't want to write it all, but that's okay. Negative 0.77, and then I can use normal distribution, either using the mean of 0, standard deviation of 1, or let's say that I was going to use Desmos, and negative 0.71. There we go. There's my normal, or there's my probability, and here it is worked out. Okay? All right. Now, if you look, gotta go back and forth, there we go. If you look at each one of these, what I've done is I've set it up and I found the probability, and you might be off by 100th or a 10th, depending on where you round. If you use the calculator. If you use the calculator, you don't have to do the z-score. So if you use your calculator, no z-score, just use second vars. If you use Desmos, you got to get the z-score and then put it in as either the minimum or the maximum. Now, down here for number 11, you have to calculate both the z-score for 77 and 83. Then this becomes your lower, this becomes your upper when you put it into Desmos. Questions there? All right. Now, you've got the third and final bit of practice. This is homework 6, z-scores and standard normal distribution. Looks very similar to the problems that we just finished doing. You've got some that you have to find the z-score of, some that you're given different bits of information, either the z-score, standard deviation, mean, or data item, and you've got to find, you're given 3 of those pieces of information, you've got to find the other one. So that means that you're just simply doing z equals x minus, I'm just going to use a u for mu, divided by the standard deviation. Okay? So that's where you are using this information. Okay? Now, go ahead, pause the video, and do the work. When you get to questions 8 through 14, remember that if it says the probability that z is less than or greater than or between, you're using z-scores. You can go straight to Desmos and just use Desmos as is, or on the calculator, you got to remember that your mean is 0 and your standard deviation is 1 for z-scores. If on the other hand, it's asking you the probability that x is more or less than something or between something, now you're using your data. You either have to calculate z-scores for each piece of data and then use Desmos, or you can just use the calculator directly. Pause the video and check them out. Okay, you're back. Hooray, hooray, hooray. Let's check it out. Okay, up here, z is equal to the data item minus the mean divided by the standard deviation. Were you correct? Did you get your correct answers here? Hope so. All right, let me put this down. When you got down to number 2, 3, and 4, these were given in application scenarios, and you either had to find the actual data value, or you might have had to find, in these first two, you were finding the data value. In the next two, you were finding the mean and then the standard deviation. Again, there are 4 pieces of data or 4 pieces of information for the formula. You must have 3 of them, and you can find the 4th item. Number 6, you need to find the data item, and number 7, you were looking for the mean. You also needed to find out, did Xavier get an A for the year? And it turns out that no, he did not. He got a 94, so he didn't get that A. He was close. Now, for questions 8 through 14, notice that 8, 9, and 10 are all referring to z-scores. Therefore, for each one of these, the mean is equal to 0, and the standard deviation is equal to 1 for 8, 9, and 10. All right, so if you used your calculator, you used the value of z, mean of 0, standard deviation of 1, and then your max and min accordingly. When you got down to 11 through 14, you're working with the actual data. Now you're talking about the mean being 58, in this case pounds, and the standard deviation is 17.2 pounds. You're going to use that for all of these when you use the calculator. If you're not using the calculator, and this is if you use the calculator, you're going to use this. On the other hand, if you're going to use Desmos, you first have to calculate z-score. Then remember that your mean is 0 and your standard deviation is equal to 1. Either way, your numbers will come out about the same. Now, the one thing about this worksheet that I'm not real pleased with is it's asking for the probability. The probability is not 65.91%. The probability is 0.6591. Again, the probability is 0.5008. The probability is 0.0582. I don't like the fact that this particular worksheet, the key is confusing probability and percent, because they are actually 2 very different things. So you need to make sure that you are doing it correctly. Okay? So again, numbers are the same. You just have to notice probability between 0 and 1, percent between 0 and 100. Next up, number 15, the high temperatures in Virginia Beach during the month of July are normally distributed with a mean of 83 and a standard deviation of 6. Find the probability on a given day that during the month the temperature is greater than 92. Again, probability, so this should be 0.0668. The probability that someone watches between 3 and 5 hours a day, 0.5938, no percentage. The mean song length of Jack's iPad, the probability, again, that's between 0 and 1, should be 0.9599. Okay? That's it. Again, if any of this asks the percentage of songs that are 3 minutes, that are no more than 3 minutes and 45 seconds, basically less than that, you would then say it's 95.99%. But you would not give that as probability. All right? That is all. You're done. Now, you will be able to, when it comes out, get the summative review and have that completely prepared. Your summative test will actually be in May, either just before the SOL, maybe just after. It all depends on our weather and how quickly we can move through things, and if there are any other issues that cause us to pause. All right?